So till now we have described the classical hepatic lobule. Now as I told you that each hepatocyte is like a cube, and if we see that two surfaces of each hepatocytes, they will come in contact with the sinusoids, whereas the rest of the four surfaces, they are surrounded by the adjacent hepatocytes. Now these green channel is like a canal which is surrounding this the surfaces of the hepatocytes, which are shared by the adjacent hepatocytes, and these green channels are bile canaliculi. So if these are two hepatocytes which are arranged adjacently, then we can see that each are surrounded by a bile canaliculi of its own, which is continuous with that of the other. Hence, now we need to describe another type of lobule in the liver, which is called portal lobule. So if this is a classical hepatic lobule with 6 sides, central vein, portal triad, so you see this hexagon with center formed by the portal triad is called portal lobule. So portal lobule is also a hexagonal structure, the center of which is formed by the portal triad, and at its periphery, at 3 ends there are central veins, and at 3 ends the portal triads. Now what we have seen, that if this is a lamella, another lamella, and this is the sinusoidal space over here in a classic lobule, then what do we see? Around the hepatocytes, the bile canaliculi are present, and these bile canaliculi, they move towards the portal triad in the direction opposite to the direction of the blood in sinusoids. So the bile is collected from the bile canaliculi. All the bile canaliculi join to form canal of Herring, which join to form bile ductules, which are present at the portal triads. These join to form either right or left hepatic ducts containing bile. So you see, portal lobule is an exocrine unit which the center of which carries or center of which contains the bile. Whereas classical hepatic lobule, it is a venous unit, the center of which is occupied by the central vein, which collects the venous blood. Now this portal lobule is visible only in some pathological structures, when the classical hepatic lobule is not that much evident under microscope. Third thing is the liver acini. Now again, first I will draw the structure of a classical hepatic lobule. Central vein, portal, triad. Now as I have shown in the first figure, these three structures of the portal triad, they also give horizontal branches which join with each other at the periphery of the hepatic lobule. So these are the transverse channels. Now suppose if I consider this hepatic lobule and this hepatic lobule, then I can make another diamond shaped, I can delineate one diamond shaped area, the ends of which are occupied by the central veins of the two classical hepatic lobules and other two ends by the portal triads, and the center of which is formed by the transverse channels. Now what is the purpose of this liver acini? You see, the center of it contains the transverse channels or transverse branches of the hepatic artery and the portal vein. So this area is highly oxygenated and is very much rich in nutrients. So all the hepatocytes which are present near this area, they are well oxygenated and receive good supply of nutrients, but along with the nutrients they will also receive more of toxins. So if there are more toxins in the blood carried by these vessels, so these cells in this area, they will die. As we move away from these transverse channels, oxygenation and nutrients decrease as well as the toxins. So these are divided into three zones: zone A, zone B and zone C. Zone A is the area which is very near the transverse channels, B is away from it and C is farthest. The cells in the C are most protected because they will not receive much of the toxins, but at the same time they will receive low oxygen and less nutrients. So this was all about the liver acini. Thank you.